I have nearly this situation for my 80 meter inverted V dipole because of mounting constraints. Height of antenna feed point is about 5.5 meter from the ground. Ends are at about 4 meter from the ground. There is a 1:1 current balun at feed point, an ugly balun in the shack with 15 turns of RG58 on 4-inch PVC pipe, and a common mode choke wound on FT240-43 toroid with 11 plus 11 turns of RG316 coax. When the two limbs or elements of a single inverted V antenna are arranged at right angles, 90 degrees to each other, in the horizontal plane, the antenna is effectively a bent dipole viewed from above. This specific geometry creates several distinct shifts in performance compared to a standard straight inverted V. These are the possibilities which I got online. A standard inverted V has a fat figure of 8 pattern radiating more strongly broadside to the wires. By bending the limbs to 90 degrees horizontally, the nulls, the dead spot of the ends of the wires, are significantly filled in. The antenna becomes much more omnidirectional, radiating more equally in all directions. The peak signal will generally favor the direction of the V is pointing, bisector of the angle, and the area directly opposite it. While a straight dipole is primarily horizontally polarized, this bend configuration introduces a significant vertical component to the radiation, especially towards the ends of the wires. This can be an advantage for local contacts. Bending the limbs closer together lowers the feed point impedance. While a straight inverted V is often close to 50 ohms, a 90 degrees horizontal bend can drop the impedance approximately 30 ohms to 35 ohms, which may result in slightly higher SWR on standard 50 ohms feed line. You may need to slightly increase the length of the wires by about 3 to 5% to maintain resonance compared to a straight dipole, as the proximity of the limbs increases mutual coupling. Though this is the theoretical aspect, actual impedance which I noted on the nano VNA Smith chart is near 50 ohms with very little reactive component. There is much more complexity to the antenna other than the 90 degrees horizontal bend. Midpoint of one limb has been elevated to about 10 meters from the ground, again due to mounting constraints. 40 meter inverted V and loop antenna for 40 meter are nearby. One limb passes between two nearby buildings. Somehow these complex interactions have brought the impedance near 50 ohms and SWR near 1:1. Would like to know your thoughts on similar complex antenna mounting situations which are very difficult to model.